welcome to my YouTube channel, Automation Bypass. On this channel, we're going to discuss the concepts of industrial control and automation, right? In this series that I have presented the practical knowledge and skills of the trade that I have acquired through my experience. Now we're going to start off with very basics and then move our way to advanced level so that beginners, professionals, all alike can benefit from this course. The goal of this YouTube channel is to build an engaging community so that we can all learn and grow together. Kindly share any interesting questions or industrial solutions or any tips and hacks in the comment section so that we can all learn and develop from it. Our starting point is going to be from switching, and then we will move across the board to advanced level. And finally, we're going to have a Q&A session so that we can all revise and learn together. So without further ado, let's begin with switching. Now, if someone asks you what is industrial control, the simplest answer that you can give is switching. Let me explain. Industrial processes are comprised of electrical equipment such as fans, motors, valves, pumps, etc. And what you want for them is to turn them on or off under particular condition. For example, time duration, for example, after a certain number of counts, or in a specific sequence. So, not to get ahead of ourselves, you will hear these two terms quite frequently in the world of electrical control. These are open and close. One thing to keep in mind is that in the physical world, if I say that the door is open, that means the path is clear and you can enter. However, this is not the case in the world of electrical switches. If a switch is open, this is the symbol for an open switch. That means that the power cannot flow freely across the switch, and hence any load that is connected to the switch will be off. And on the contrary, if I say that the switch is closed, that means that the current or the power can flow freely from source to the load, and hence it is connected and the circuit will be on. So one thing to keep in mind is that electrically open switch is accompanied by a off circuit, and electrically closed switch is accompanied by a on circuit as indicated by 0 and 1. So back to the board. Now this is a normally open switch. This here is a normally open switch. It is shown by the color green and number 1314. Any number that ends with 3 and 4 is usually depicts the normally open switches. These are industrial standards. Normally closed switch is indicated by the red color, and it is often shown by the number ending with 1 and 2, for example 21 and 22. So something to keep in mind. But wait, what exactly is normally? What does normally implies? What does it mean? So it implies that there might be another state which is not normal. So let's call this state actuated or forced. So what I'm trying to say is that a normally open switch can be forced close, and similarly a normally closed switch can be forced open. For example, look at this diagram at the right side of the presentation. Now, here we have an electrical power source, battery, and it is connected to a load bulb, right? And as you can see that the switch in this case is NC, normally closed, because as you can see this spring is holding together the contacts and the current can move freely across the circuit, hence turning on the bulb. So this is a normally closed switch, but on the bottom side, you can see that this normally closed switch can be forced open. So when you push this button, it breaks the contact and the circuit is off. So normally implies that in the actuated conditions, the roles of is reversed and the circuit can be turned off or off depending on the requirement. Next, we are going to look at some configuration of these switches. Now, I want you to get familiar with these symbols because you're going to find a lot of these in the electrical diagrams. Now, this is a SPST, single pole, single throw switch. What this means that it has two terminals. One of the terminal is connected to the source and the other one is connected to the load. And depending on the condition, you can turn it on or off. The second one is a little bit interesting. It is a single pole double throw. It has three terminals, one of which is common. When you connect the power source on the common, then you have option. You can either deliver this power to the normally closed contact or a normally open contact. You can connect electrical load here or here, or you can use both of them together, but there is a catch that these load will be electrically insulated, electrically interlocked. What I'm trying to say that one of them will work at a time, they cannot both work simultaneously. The next we have DPST, double pole single throw, and in this is the NO configuration of DPST, and this is the NC configuration of DPST. As you can see that the contacts of the switches are coupled together, so that when you force the condition on the switches, they will both move together. Similar with the NC. And the last one is DPDT. It has two commons, two NC and two NO. So a total of six terminals, and the diagram or the depiction of such a switch is shown on the right side. So these switches can also be paired together. For example, in the diagram that I'm drawing for you guys now, here we have three switches. Two of them are NO and one of them is NC. And all of these are coupled together so that when you actuate the switch, all of them will change its place, all of them will change its state simultaneously, and the NO will become FC and the NC will become FO. So something to keep in mind. We will end this lecture here, and in the next lecture we will look at the smart switches and how they work. Thank you so much. See you in the next one.